let's take an example. Point P1 is 2, 3 and point P2 is 12, 8. We can find the slope m equal to x2 minus x1 is the point plotting 2, 3 x1 y1 and 12. Here is the 12 and 8. x2 and this is y2. So now we can find the slope of x like y minus y1 and x2 minus x1. Now we can get y2 minus y1 by x2 minus x1. Now we can calculation this side 3 5 by 10 0.5 equal to m. Here we can see the value of m is less than 1. So when we plot the line x and round y, as we know that area that works on initially floating point and both integer point value. And the next point plotting is x plus 1 and y plus m. The value of m is y plus 0.5. That means when we round the value of y, we get the value of y is 1. When we calculate the positions on graph, we have a table of 4 columns, x, y, this is x plot and y plot. According to equations, the value of x is incremented by 1 for plotting the next point pixels. Then we have the value of x1, that is 2, and the destination value of x2 is 12. Then the value incremented in start point to end point is 1. So we can take the value of x is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. see the value of y is 3. We plot the value 3. And the incrementation of y coordinates is 0.5. So the next value of y is y equal to y plus 0.5. Then we can value y is 3.5. Next the y is y equal to plus 0.5. Well, the previous value of y is 3.5. When we add the 5, then we can get 4. And this step is incremented in so what? That's this is 4.5, this is 5, this is 5.5, this is 6 and 6.5, this is 7.5. And when we plot the next point on x and y plane, then x is incremented by 1. So no change exploring point 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and with the value then your x variable works on floating and is a point. It is a point value. So the y is 3 and the value of y is 3.5, and when we round the value of 0.5, round 3.5, we can get the value. So the y plotted on, and again when plot round 4, we get the round 5, round 4, we get the value 4. When we put the value of y 4.5 and round functions, then we get the value 5, and when we plot 5, then we get the value 5. When we plot 5.5, then we get 6. When we plot 6, then we get 6. When we plot 6.5, then we get the value 7. When we plot 7, then we get the value 7. When we plot 7.5, we can get the value 8. And when we put the value 8, then we get 8. So when we plot the line, we get the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 1, 2, 3, 4, 5, 6, 7, 8. The first initial value is 2 and 3, x, y. X is 2 and y is 3. And the last plotting value is 12, 8. plot the line 2, 3, 2, y. Plotting pixel is x3, y4. Next 4. And next 5. Next 6. 6. 7, 6. 8, 6. 9, 7. 10, 7. 11, 8. 12, 8. When we plot the line according to this plotting point, when we zoom the line, we can get the jack is on line. Conclusion of DDA is we may implement rounding function and floating point calculation. It is more time consuming or more expensive for computers. In this example, computer implement five rounding and 5 floating point computation. So these all are the disadvantage of DDA, that is the more time consuming because of floating point and rounding functions, and so we can implement Bresenham line generation algorithm to substitute of DDA. We can implement Bresenham line algo for plotting pixels on screen while this algo works on integer point calculation. So this course is less expensive, or it is less expensive in compared to digital differential analyzer.